All right, thank you everyone. Thanks for the intro. It's one of those intros that when you hear it out loud, it doesn't sound very good. It looked better on paper for people to read than spoken out loud. But anyways, hi everyone, nice to meet you all. I'm Ankur. So I want to talk to you about building. And building because, let's be honest, building is one of those boring subjects. It's something nobody enjoys. You're probably almost everybody, I'm sure, is familiar with this XKCD comic. We've all, at some point in our lives as software engineers, done this, right? Well, maybe not fencing, but found something to do whilst our builds were in progress. So it's a commonly accepted problem. And actually what's happened over time is that, mobile apps started pretty small. We'd have small code bases, but Android's a platform that's been around for a long time now, or any other platforms that you're building for. Our code bases continue to get bigger. Our users keep asking for more features. We tend to find more and more useful dependencies to include in our applications. And all of that results in slower builds, right? So you can look at that and go, yes, I know that this is an issue. And then occasionally, from time to time, you'll get a situation where someone will, hit the ceiling or just be like, oh, this is pathetic, it's too long, we need to fix this. And so you go, okay, well, how do I fix this? The traditional way is that you optimize, right? You try to work on, so the x-axis there would be basically all the different things you might try. You might try to look at your source code and see what are the bits that you're no longer using but you're still compiling for some reason. You could look at your dependencies and see if you've got additional dependencies in there that you could strip out. You could maybe look at splitting your app up into components that perhaps you could build in parallel. You could look at better tooling. You occasionally will find tools that can do the same job in a quicker way. But ultimately though, it'll end up similar to this graph where at some point you're going to get diminishing returns. At some point the extra effort that you put into making your build times faster isn't going to be worth it because you're not getting as many benefits as you might as you would have at the beginning. So what else could you do? Well, the other obvious one is, hey, you could just buy faster build hardware. Now, I'm sure all of us would love to have the latest and greatest workstations and laptops, but usually these things come in cycles. When we're building on any sort of on-premise infrastructure, we'd love to be able to upgrade those build servers so that they built our code quicker. But the thing about hardware cycles is it's not realistic for us to constantly be up to speed with that. It's not something that we can always just keep buying. We're going to end up with basically spending a ton of money and not necessarily getting the results. So there is a space, however, that we could look at, and that's in the cloud, right? And the reason that the cloud is an interesting place to consider doing our builds is that cloud providers like Google and Amazon, Microsoft, and others it's their business to make sure that you have the latest and greatest hardware. That infrastructure is super up to date. The network capacity and storage capacity is always available. So the cloud is a space that's constantly evolving, constantly on the bleeding edge. So at Google Cloud, what we did is we built a product around that, around building applications. Now, one thing I should say is that we're going to talk about Google Cloud Build today. It's not specifically built for Android apps. It's built for all sorts of different applications that you may run on the server. But today, we're going to look at how Google Cloud can be used, Cloud Build specifically, can be used for Android apps. Now, before we get too far down that, I want to introduce some of the concepts of it. So what Cloud Build is effectively a continuous integration and delivery automation service. It means that you can trigger your builds manually, or you can set up build triggers and have those builds kicked off automatically depending on commits, depending on tests, depending on a number of results. Maybe you are the type that just likes to build, your organization likes to build nightly builds or weekly builds. So you can set up kind of cron job style builds as well. But you don't just have to stop at building. You can run tests, you can publish your apps. We'll look at some of that as well. The other advantage of not having your own actual physical hardware to build is that you don't need to manage the hardware itself. You don't need to worry about the operating system. You don't need to worry about security updates to the software that needs to be there just to keep the hardware going. Cloud Build is a paid product. We heard about Firebase UI testing earlier. Firebase Test Lab. Similar to that, this is a paid product. There is a free tier, and I'm going to talk about that in upcoming slides as well. So let's look at some, like, how we get started with Cloud Build. But before we go into the Android space, let me just introduce some of the concepts that are important for Cloud Build. First is that it takes your source code on the left and actually will put it in this mount point / workspace. And you'll be able to then describe a build specification, or think of it like a recipe that says these are all the things that I need to happen to my build. Now we call these build steps, and these build steps can happen in parallel. What will then happen is it will run whatever your build steps are. You're going to declare them, and you'll get a bunch of artifacts at the end of it. Now, in order to do these build steps, we need something to operate on your source code. So just providing your source code obviously isn't enough. You need what's called a builder. In the case of builders within Cloud Build, these are containers. These are container images. Now, so for those of you that are not familiar with containers or have only heard the term but aren't really sure what it means, let me use a metaphor of what a container is, just a quick brief description. If you think about a virtual machine has to virtualize everything. It virtualizes the CPU, the graphics stack, the network stack, the storage, and everything. It runs a full copy of whatever operating system you're virtualizing for that machine. Containers do away with that. Containers say, hey, you know what? We know that what's in this container is just the application, just the binaries that we need to run, and we've got them nicely sandboxed. So compared to virtual machines, you can stack a whole bunch more containers on a single machine because you're not incurring the cost of virtualizing the hardware, of having multiple copies of the operating systems running, and so on. So containers are kind of nice in that sense. In the context of Cloud Build, think of containers as just a packaging format. And this packaging format for you is your tool chain. So now bringing it back to Android, what we're going to do is create a builder that contains all the Android toolchain. So the SDK, Gradle, any of the compilers that you're using, any repos that you may have, so things like Jetpack and so on as well. So the nice thing about a container, you may say, oh, this sounds like a lot of work. But if you think about what we want to do is we want to have a build set up in our organization that's reliable and repeatable. And we want to save time. Remember the problem statement at the start was, how do we save time? So up front, if we go and create our builder, that same builder can be applied to every engineer on your team because they don't have a variation of it. Think of that container as kind of like a glorified zip file in this context. It just contains all the right tool chain and it's nicely sandboxed. So what we need is this builder to go ahead and do our build steps. And we're going to use multiple builders in the example that I talk about today. So let me show you, sorry, I'm going to have to get out of full screen mode. So here is actually the Google Cloud documentation, and I apologize, this looks a bit small. Cloud actually provides a set of, let me scroll down for those people at the back. Cloud actually provides a set of pre-built builder images. And so you'll see there's one for Git, there's another one for Go if you program in that language. There's also one for Gradle. This is not the one you should use. So first trap, don't fall for this one. Because this is just the Gradle toolchain. This isn't specialized for Android. And today, we don't have an Android builder here. And that's actually, in some ways, in my opinion, it's a good thing. Because I can tell you now that you're going to have variations to the way you want to build your Android apps. So a single Android image is probably not the right thing to have here. Instead, what we also have is, and I'm going to zoom in here as well, is on the Cloud Platform GitHub repo, we have this Cloud Builders community. And this is a group of people that create all sorts of utilities for different types of builders and other utilities that you might use to use Cloud Build. But if you scroll back to the top, you'll notice that they have an Android builder. And this talk is really built up of a lot of work that's being done by the community here. So what we're going to do is use their recipe for building an Android builder, and I'm not going to dive into how we build the builder, where right now we'll leave that, I'm going to leave that exercise to you if you really want to look at the nitty-gritty. What I can say is you can use this, it works, and the rest of this talk will focus on other things. So remember I said that we had these different build steps that could all happen in parallel? In order to declare those build steps, you have to have a build config. This is a YAML file, and in this YAML file, you can specify your actual steps, you can specify things like timeout values and so on. But when it comes to running tasks in parallel, at some point, you need to have dependencies. So for example, you're going to have a step that says, hey, go compile and build my actual code. And then once those APKs are generated, you're going to want to take those APKs and store them somewhere, wherever you publish them, right? So the point that goes and stores the APKs, that needs to have a dependency on the build completing. So in this build step, we would put those sorts of dependencies in here. The other thing I want to make very clear to all of you is that this isn't about replacing your current build config. So your build.gradle, I'm sure you've spent many hours putting those together. You heard in the last talk how difficult, or even earlier talks, how much effort goes into that. This is really about building on top of that. This is about saying, hey, you've already got a build process. We're going to automate it using Cloud Build. So we're going to just call your same build scripts. We're not changing that part of it. And then in terms of looking at these builds, we use the Google Cloud Console UI. So let me get out of full screen again, and let me go into this thing. Let me zoom in. So basically, this is our console where once you've kicked off builds, they're going to show up here. We'll look at how all of that happens. But here's one that I did just a little while ago, just earlier today. I kicked off a build. How many of you have used the Google I/O app in the past? Many of you? Okay, so we open source that. You can grab the source code on GitHub. So I just went and built that actually in my build step. And so you'll see that I have a number of build steps here that does a number of things. We're going to look at what all those things are. But the big one here is the actual build itself, which goes and calls Gradle W. Let me zoom in again so that you can all see that. It just goes and builds the debug version of it, passes in a bunch of options, and then we can see all of the build logs in this window here for this build step. So what I'm trying to say is once you've submitted a build, you don't need to sit there and watch the terminal for the rest of the time. It all just happens in the cloud. Going back to it. So now we've covered some basic concepts of Cloud Build itself. Let's look at what's involved for Android. We're going to start working out some build steps for building your Android apps. The first one I want to show you is just, oops, sorry, I had set this up as multiple windows, but once I knew the setup, I've had to change to tabs. So in the Google Cloud Console, basically, what I've got is my source code is living on on one of the Google Cloud servers. So I've just got a shell into my server. I'm going to go into Cloud Build and Demo. I'm just going to show you what the kind of file structure looks like here. Can you all see that? I might move it just a little bit further up. And what I've done is effectively we're going to have 3 things and then 2 source repositories. So there's 3 files. One is app.sh, the other is builders.sh, the third is cloudbuild.yaml, which is our recipe, our build steps. And the other 2 folders, the directories there, one is just that repository Cloud Builders community, and the other one is IOSCED, the source code. I'm not modifying any of that, okay? The first thing that we'd want to do is just look at which builders we need. In our recipe, in our cloudbuild.yaml, we basically need 2 additional builders that don't exist, that are not built by Google, that we want to build for our purposes. One of them is actually kind of simple. It's just tar. We want the tar utility to bundle up our apps, our files, and to compress and extract. The other one is Android. And so you'll notice for both of these, what we're doing is actually submitting just that directory there. So under Cloud Builders community/tar, and what it's going to do is take its builder configuration, its Docker file, and it'll generate a builder for us. It uses the Cloud Build YAML from there as well, which is the actual recipe. Same thing, we do it for Android. One interesting thing that I want to point out is for Android, we're actually providing API version. And that's really important for Android because you're going to have apps that are targeting specific versions of the API. So what you want to do is have your builders set up that are already pre-configured for those API versions. What you don't want is for every build for it to go and fetch that version of Android, that version of the SDK for API 28 or 29 or any dot releases and so on. So this is it. Once you run this command, we're going to end up with our builders. I've already done that. It takes about a few minutes for each of those. And you'll notice that I've got, again, zoom in, you'll notice that I've got tags on these. So I've got an Android against API 28, and I've got an Android API 29 pre-built. So if we go back to it, we've got our builders set up there. Then if I just cat our app.sh, this is just a simple shell script. Unfortunately, the font size is too big. It's wrapping in funny ways, so I'll make it one smaller so that we don't get these weird wrapping. And you'll notice here that when we want to build the app, and I'll just add some new lines so that it scrolls to the top of the window so you can all see. What you'll notice is that we've got, we're saying, hey, submit the IOSCED directory. That's our source code. That's our, that's what we want to submit to Google Cloud. And we're saying pass in a bunch of substitutions and just use our cloudbuild.yaml. Now, so far it doesn't look like there's lots there. That's because cloudbuild.yaml actually contains the meat of what work we want to do here. So we've seen that that's how it's set up. Now, when it comes to declaring these build steps, it's declared in YAML. So for those of you that are familiar with YAML, this should look as you'd expect. For those of you that aren't, YAML stands for yet another markup language. It's a way to declare some of these configuration values. It's actually not too hard to learn. So despite you not being familiar with it, let me just walk you through some of the things that are important here. So you'll notice the first thing we do is specify the builder that we want to use. So what we're saying is, in this step, we're going to compile our source code, and the builder that we want to use is our project, and it's Android, and then we're passing in an environment variable of Android API. So that way, if I wanted to build IOSCED with API 28, I'd just pass in 28 on the command line. If I wanted 29, I'd pass in 29, etc., etc. And then what we do is we actually name our build step. Now this part is important, because we're going to have other steps in our build process that are going to be dependent on this. So, like the example of saving the APKs, they're going to say, hey, until the build is done, I'm not going to find the APKs. Because Cloud Build, by default, will try and run all these build steps in parallel. It'll try and optimize for you. So you need to introduce those rails in there at some point. Then what we're saying is, hey, run Gradle, say we want the debug version of it, and we're passing in a bunch of options there for the compile, right? For any of you that have built big apps, you might want to change the heap space for Java, and then just these other parameters. Not a big deal, but basically what we're saying, hey, Gradle, create parallel workers, because we know on these cloud machines things can be built in parallel. So we'll let Gradle also do its parallel work where it can. So that's it for actually building the project. Once it's actually done the build, and we saw the log earlier, what we want to do is then save the APKs. I've been referring to this for a while. So the first thing we're going to see, even though it's not in the order that you'd expect, we have this wait for at the end that says, hey, wait for the build step to complete. Remember the ID, we gave it build? We're saying wait for that before you try and do it. And what we're doing is, we're going to grab the APKs from wherever the build is set, and we've got an environment variable for that. It's going to then go and upload it to Google Cloud. There's this product that we have called Cloud Storage, and it's where we dump files. You don't have to do it there. You may use other places where you have your build outputs. You can use what you like. I tended to use Cloud Storage because, one, it's nicely integrated into Cloud Build, and two, it gives us things like access permissions and so on. So you can have users that have rights to read it and not read it. Perhaps some of your builds are sensitive and you don't want your whole organization accessing it. So you have extra controls there. But saving the APKs is as simple as just basically calling our GSUtil, which is the cloud storage utility. We're doing a recursive copy of all of our APK directory and storing it in our cloud storage bucket. And as I said, we start that. So if we look at our diagram here of our build steps, all we're doing is we're building our source, saving the APKs, and then we're uploading it to cloud storage. Now you may look at this diagram and say, this guy really sucks at diagrams. Why couldn't he just have made it left to right or top to bottom? It's because there's a few more steps coming that complicate this diagram a little bit more. But I'm not great at diagrams either. All right, so if I just look at where the output of the, sorry, this is the window that I want. If I look at where the output, I remember I said it goes in Google Cloud Storage. There's a few things that I'm storing here, but under artifacts is where it's going to dump my APKs. So these are all the build IDs that I've built over the last day or two, and you'll notice that there's an APK folder, and because we said recursively store it, I've got my debug APKs there, and the IOSCED app, you can see its APK is being dumped there. So cloud storage, we can view it. We can view it through the UI, through the dashboard that we have, or there's that gsutil command line ability, so you can go and fetch it whenever you like as well. Okay. So we've now done just the very basics, right? We're just building and saving the APKs. One of the things that you'll notice that Gradle really benefits from is the build cache. Now, if you want perfectly hermetically sealed apps, you shouldn't be reusing the build cache. You want to be building from the ground up every time. That's how you get repeatability. But in our case, we're doing a debug build. We want to do some sanity checking. We want to see if you've got compile time failures on check-in. Maybe it's a pre-submit check that we're doing here. For that purpose, you probably benefit a lot from reusing the build cache. So I just want to show you how you could basically reuse your build cache across builds to get you, I think on this app, you get a saving of about 30 to 40% in time if you just reuse the build cache, because then your incremental builds are very small. So after our build is done, so you'll notice our wait for build, what we're going to do is we're going to use that tar command to compress our cache. So we call this build step compress cache, and all we're doing is we're calling tar, we're saying create a tarball, gzip it, and basically take our Gradle cache that we generate, the .gradle directory, and just go and dump it on this volume that we go and mount called build cache. So the first step is compress it. The second step is go and store it. So now we call back to our cloud storage utility, gsutil, and we take that cache, that tarball, and go and store it on our Google Cloud Storage bucket so that the next build that needs to come along can go fetch it and then uncompress it and reuse it. So we've now done the bit where we compressed it, we've done the bit where we stored it, and of course on the next build, we need to retrieve it. So this is a 2-column view, so think of this as one set of build steps and the right-hand side as another. What we're going to do is fetch, using gsutil, we're going to fetch the build cache. We use rsync rather than cp because the cp command will error if you can't find the file, whereas rsync won't. And so the first time around, there's going to be no build cache, right? In subsequent times there will. So we'll get rsync to get it, and then what we're going to do is uncompress. We're going to use the tar command to uncompress our tarball and chuck it in our build cache directory where Gradle will then reuse it. So in terms of our steps, we've gone from doing this, we've added a few steps where before we kick off the build, we're going to fetch whatever build cache we have from any previous runs on cloud storage. We'll do the build, and then we're going to compress and store the cache back into cloud storage so that it happens in the future. But of course, we haven't done that step of signing APKs. We all have different signing keys, and signing keys are very, very important. They're often very protected as well, right? We don't want every person in our organization to have access to our signing keys. Now, Google Cloud has multiple ways that you can store secrets. Secrets is kind of a general name for these sorts of things. So an example of a secret might be your signing key. Another example is just your API key. So let's say you're using the Google Maps API or a third-party API and you need an API key. You don't want to be checking in those API keys into your source code. So we have a way to actually declare secrets. I did not want to spend too much time in this talk going into that, but we have a set of documentation on that, and we've got a number of things coming up that's going to make that a lot easier. But if we look at our actual process here, what we want to do is before we save off our APKs, we want to go and make sure that we sign them with the appropriate signing keys. And obviously you'll have different signing keys depending on whether you've got debug, release, testing, versions of your apps, and depends on which apps you're using as well. Cool. So you may look at this and go, okay, well, what other types of automation can I do here? We've looked at kind of build steps and just the very basics. Well, the first one I would say is build triggers. So right now we've looked at just running some commands and triggering our builds manually. What you can do is actually we integrate with both our own product, Cloud Source Repository, where you can use source code, but realistically lots of developers use GitHub, so we integrate with GitHub and Bitbucket as well. So you can set up triggers, so when code is committed into specific branches, you can just go ahead and trigger a build as well. So we can set up those automatic, you can set up those automatic build triggers. The other thing you might do is something I said earlier about nightly or weekly builds. You can effectively have timers that every so often you will just go ahead and trigger a build to have that type of output if you want. Cloud Build is also great for doing other things like running your automated tests, kicking them off. You can wait for those tests to come back before you report whether the build was successful or not. You can also publish using the Play Store APIs. You can publish straight to Google Play. My strong recommendation is do it to your testing channels, not to your production channels. But you can do that so that your testers can get a fresh build as soon as it's ready, as soon as you've got whatever the relevant commits are. So if we look at kind of the end state of our diagram, what we might want to also do is set up some extra steps where after we've signed our APKs, we also go and run our automated tests and we publish to the Play Store as well. Finally, I want to talk about a couple of build options that you have. So remember I said earlier on that you pay by the minute. So one thing you might want to have is a global timeout. If there's something that's hung on your build, you can set a timeout where we will kill the build before it just sits there running for hours and hours on end if you've got something that's like a tool that's kind of hung or something like that. So you can set the timeout to whatever value is relevant. But the other two options I think are really, really important. One is the type of machine that you want to run on. So with Cloud Build today, we offer 3 machine types and they vary in price. That's the next slide. I'm not trying to hide that. But here is where you would basically specify it. And then the last one is, I think, a best practice that everyone should follow on Cloud Build is this substitution option called must match. So in our Cloud Build YAML file, you'll notice we had substitutions. We had the Android API, we had the APK path, we had the Google Cloud Storage bucket. By specifying this option, it basically says that if I don't have a value passed in to my build for any of those substitutions, abort straight away. So it's kind of like a compile time check for your Cloud Build specification. And so I really wish this was a default option, by the way, because I think you never want to get towards halfway through your build and then realize you forgot to specify some option. So as a best practice, I strongly recommend that you do this. All right, in terms of pricing, with Cloud Build, one of the things is we have 3 different specs of machines that we offer. The first one is this, we call it N Standard 1. Now, I know these are funny names, but these are kind of special cloud names that we have for different types of hardware. But the thing about that N Standard 1 is, even though it's only got a single virtual CPU and 4 gigs of memory, you get 2 hours of build time on it every day for free. Build by the minute. So if you want to just go try out Cloud Build, that's a great place to start. In general, I find Cloud Build, even with 1 virtual CPU, runs rings around my laptop. So IO Shed takes over more than 10 minutes to build on my machine. On N Standard 1, it was around 8 minutes. In fact, I have the exact build time that I can show you. Just zoom out a little bit more. Yeah, see this 8 minute 47 seconds was on N Standard 1. So it took 8 minutes 47 on that N Standard 1. The next level up, the next tier up, is actually the one that I highly recommend, which is this high CPU-8. And I'm not a salesperson, so I'm not trying to tell you so that we get a few more cents. The point is that you get 8 virtual CPUs, so you can parallelly build a lot more stuff. It's super fast. And actually, if you look up our documentation, each of these spec machines, we actually tell you what generation of Intel CPU it has and so on, so you can get performance characteristics. But the point is, for about 1.6 US cents a minute, you get a really, really quick build with 8 gigs of RAM. And actually, to just support what I was saying, that I'm not trying to sell it to you, unless you've got a really, really big app, I wouldn't bother with the 32, the highest tier, because the difference, the time difference is kind of marginal. At least in the IO Shed example and some of the others that I've seen, I didn't think that the benefit was worth the additional cost. That middle one is definitely the sweet spot, but if you just want to check it out, that N standard one, 2 hours every day, free build time. So, look, coming back to, just to wrap up, what we started with was build times suck, right? Like everybody hates having to wait. Cloud Builders is a really great way to build, because one, you get this repeatable process. Because we have these concept of builders, everyone's using the same tool chain. You never get in a situation where Sarah's build works and Richard's build fails 50% of the time, because everyone is working off the exact same build template. It hooks up nicely to your CI/CD system, so that it provides you your CI/CD system, so you can do other things like testing and publishing and so on as well. And ultimately, it means that you can always be on the latest and greatest hardware when you choose. It's literally changing that one build option that we had for CPU type if you need something more. So today, everything we looked at is actually, you can see it on the Cloud Build documentation. But the thing that I really recommend for you all, because remember, Cloud Build, I said it's a generic build product. This community, Cloud Builders community, has some really great stuff for Android developers. And there's a couple of, if you just do a Google search for Cloud Build for Android, there's a couple of great blog posts as well where people have written about their experience. So give it a try. Let me know if you've got any questions. I'd be happy to help out. Thank you very much.